All right, cool. So this is a more expedited version of the boot camp. The goal is to, you know, make everything just fast, just make everything faster. Okay. Um, so let's just go ahead and dive in. All right. So welcome to the boot camp. This is really just going to teach you everything you need to know from not even knowing what a hard drive is all the way to being a cloud engineer doing projects like real world projects, like literally stuff that I do at my job. Okay. And having the skill set of being a AWS cloud engineer. Also, as a bonus, what you have in the course already is everything you need to consistently get interviews. Okay. Everything you need to um, like get an offer letter, like everything. So articulating the information, creating your resume, LinkedIn, getting recruiters reaching out to you, bombarding you, like having the skill set to pass interviews. Keep it very simple. Cool. Now, um, what you'll learn, just real quick, the first thing, well, just to keep it simple, you're gonna learn AWS Cloud Engineer tools and technologies. So AWS core services like EC2, S3, VPC, IAM, RDS. It's like the core AWS services. Cloud security best practices, right? How to secure your environment, infrastructure as code, continuous like CI/CD, what that is, containers and orchestration, monitoring and just observe monitoring. Okay, once you build your infrastructure, how to monitor it. And so moving forward, anything that might seem like, I don't know what he's talking about. Some things you won't be able to understand until you finish the program or you see the big picture. Okay. I'm not going to go super in depth. This is straight to the point. Anything you do not understand, you have the ability to go out there and use ChatGPT. Okay. You will have access to the notes, everything I'm going over. Anything you do not understand, write down your notes. You can access it at the end. But more importantly, independently go through Chat. If it's a ChatGPT question, definitely copy and paste your question and put it in ChatGPT. If it's something that you do not understand, write it down, type it out, and then ask ChatGPT, hey, can you explain this a little bit further? This is just to get through the information as fast as possible. Cool. So, right, first things first, first concept, first lesson, understanding computer hardware. Okay. So, CPU stands for Central Processing Unit. Think about this. This is pretty much like the brain of the computer. Okay. The analogy is think of the CPU as a chef in a kitchen. The chef, the CPU, takes orders, instructions, processes them, and prepares meals, which is the outputs. The faster the chef, the quicker the food is ready. Example, a computer is running multiple applications at once. A computer running multiple applications at once needs a fast CPU to process all of the data smoothly. Moving forward, RAM. RAM, some people call it memory, right? Well, not some people. Like if you hear memory, they're typically talking about RAM, but it's more so like the short-term memory. Okay. We just talked about the CPU is the brain of the computer. Now we're talking about the RAM. It's the short-term memory. And the RAM is like a notepad. The bigger the notepad, the more things you can jot down and refer to quickly before erasing. If your notepad is small, you have to erase and rewrite things often, slowing you down pretty much. So an example, okay, an example is when you open multiple browser tabs or programs, RAM stores and the active data so you can switch between them quickly. If you don't have enough RAM, your computer slows down because it has to keep retrieving data from the hard drive. So just another, literally, if you're on your computer and like you have like 50 tabs open on on Google Chrome. Let's say you have 2 gigs of RAM. Your computer is going to be very slow because it's you're trying to do too many things at the same time on a small notepad. But if you had 8 gigs instead of two, you have a bigger notepad. So you can multitask. You can do multiple tasks. Hard drive, storage. This is like the filing cabinet. Think of a hard drive like a filing cabinet where you store documents. The bigger the bigger the cabinet, the more files you can keep. The bigger the cabinet, which is the storage, the hard drive, the more files you can keep. When you save a picture or a video, it goes onto the hard drive. If you run out of space, you either delete old files or get a bigger hard drive. Cool. Excuse me. Now, now that was lesson one, right? Literally understanding computer hard drive. We just learned about CPU, RAM, and storage. Lesson two, we're going to talk about software versus hardware. This is very simple. Hardware, let me actually let me make this side by side. Cool. Hardware is like, it's the physical parts of a computer, okay? It's like the body of a car, things you can touch, like the engine, tires, steering wheels. So for a computer world, a keyboard, mouse, monitor, right? And hard drive are all hardware components because they are physical. Software, these are the instructions that make the hardware work, right? Software is like the driver of a car. Without a driver, software, the car, the hardware, just sits there. Example, Microsoft Word, video games, an operating system like Windows are all software because they give instructions to the computer to perform a task. Okay. Now, the difference between the difference between hardware and software, it's very simple. Let's keep it, same thing I kind of just said. Hardware equals physical components like a phone or laptop. It's something you can touch. Software, the programs and apps that run on the hardware. That is is the reason why I'm teaching this, because when we talk about building a server, building a computer, and then installing a software and application on that hardware, like you're going to see that everywhere in cloud engineer. Containers, right? EC2s, installing an application, workplace application on there. That's why I'm starting from what is the hardware, what is the software? A software is the programs and apps that run on the hardware. Right? An example, analogy is a phone is the hardware, but the apps inside it, like Instagram, YouTube, are software. Okay. Now, lesson three, exploring operating systems. An operating system is like a traffic cop. It directs where information goes and ensures that everything runs smoothly on your computer. Example, Windows, Mac OS, Linux are all operating systems that help run applications and manage hardware. Okay. So we just learned about hardware and software, and now we're learning about operating systems and how they help run applications and manage hardware. Okay. Now, there's only 3 operating systems you have to know, and you already know 2 of them, Windows and Macs. Well, Mac is like the operating system specifically is called Windows, like Windows 11, Windows, 10, et cetera, et cetera. There's different versions of Windows, and this is the most common operating system for personal and business use. If you go to, anyways, Mac OS, right? Mac OS operating system, that's the name of the operating system, is used on Apple computers, popular among designers and developers. Anything relating to something like artistry, right? Photography, DJing, like just different stuff in that arena, probably going to use a MacBook. Or, yeah, you're probably going to use a MacBook or a MacBook Air, but the operating system, right? The MacBook Air is the name of the computer, it's the name of the hardware, And the operating system that's running on the hardware is the Mac OS. And then and then the third operating system, okay, is Linux, okay, which is mostly used by IT professionals and servers because it's flexible, it's secure, and open source. If your computer runs Windows, you can install Microsoft Office. If you have a Mac OS, you use Apple's ecosystem. If you're using Linux, you may have more control over the system's customization. And so those who are doing the projects and tech challenges right now in the program, you kind of have an idea of what I'm talking about because when you're trying to build a server, when you're trying to install applications on there, configure stuff, you're not doing it on Windows, you're not doing it on Apple, you're doing it on Linux. Sorry, when I said Apple, I mean Mac OS. You're not doing it on Windows 11, 10. You're not doing it on Mac OS, right? That's the correct terminology. You're doing it on Linux, a flavor, a Linux distribution, a flavor of Linux, right? Because there's different variations of Linux. Cool. CLI and GUI, right? We're not talking about Nickelodeon, right? Something that's GUI, some slime stuff. We're talking about graphical user. And so let's take a step back. So CLI versus GUI. This is how we interact with computers. CLI stands for command line interface. This is using text commands to operate a computer. Back in the day, we didn't have like icons like a folder or uh like uh like a mouse, right? To double click on an icon. We had to use the keyboard to type commands to interact with the computer. That's the command line interface. GUI stands for graphical user interface. This is using a visual interface like icons in Windows. That's like the folders, the icons. You could double click on it. You could double click on the Microsoft Word on your computer, stuff like that. CLI is like sending message with Morse code. Powerful, but requires skill. It's more powerful. You can do more stuff, more customization. GUI is like using a smartphone. It's easy and user-friendly. Example, in CLI, you type CD space documents to open the documents folder. In GUI, you just double click the documents folder. Cool. Next lesson. Lesson 4, Introduction to Virtualization. What is virtualization? Okay. So before we even start talking, it's almost impossible to take notes like verbatim everything I'm saying. You could probably like type it or summarize it when you're writing it. But the main thing is to understand this is being recorded. You'll be able to go back, pause, et cetera, and take notes. Keep that in mind. As long as you understand what I'm saying, that's good. And if you don't, write down your questions. And then wait until the end. So, lesson 4, Introduction to Virtualization. What is virtualization? Virtualization allows one physical machine to run multiple virtual machines, VMs, abbreviation, by simulating hardware. Okay. Imagine one large horse. Sorry, I said horse. Imagine one large house that's been divided into separate apartments. Each apartment, virtual machines, has its own space, but they all share the same building, the physical machine. So an example is a company has one powerful server. A server is a computer, side note. Literally, when I talk about a server, that means, hey, that's a computer. Going back, Example is a company has one powerful server, but needs different environments for testing. So they need different environments for testing, development, and production. Instead of buying separate physical servers, different computers, they create virtual servers using software like VMware or Hyper-V. VMware, side note, VMware or Hyper-V literally is a software that you can install on your computer. Once you install that software, you run it, and you can literally create a virtual computer, virtual server on using that software. So on your computer, if you want to make 3 virtual computers on your main computer, you install VMware or Hyper-V. It's a software. It's a hypervisor. And then you can literally click create virtual machine. You choose how much CPU you want, how much RAM, how much storage, and it's going to take that hardware, those specs from your computer. If you have 10 gigs of space on your main computer and you create a virtual machine and you want to use 2 gigs, you're using 2 gigs of the 10 gigs of your main computer. It's borrowing from your computer. So going back to the analogy, imagine one large house, that's your computer, that's been divided into separate apartments, that's virtual machines. Each apartment has its own space, but they all share the same building. They all share the same resources. Okay, cool. Why is virtualization important? It saves money. You don't need to buy another physical machine. I have a gaming computer. I'm not going to go in depth, but it it saves money. Put it like that. You don't have to buy another computer. Increases efficiency. More work done on fewer machines. Allows quick setup of new environments, right? You don't have to wait a week or 2 weeks or whatever to set up an environment because you have to go buy some stuff. You could just download a software or even go to AWS and create a virtual machine in seconds. So an example is cloud providers like AWS use virtualization to rent out virtual servers instead of selling physical machines. They're not in the selling machine business. They're not in the selling server business. They're in the renting servers business. So example of a server, in AWS, there's something called an EC2 instance, EC2 instances. They are virtual machines running in the cloud using virtualization to share hardware resources. Cool. It's going to be good. Cool, cool, cool. Now, cloud computing concepts. What is cloud computing? Right. Now we're diving more so into AWS. What is AWS? What is cloud computing? What is cloud? What is that? Cloud computing is renting IT resources like servers, storage, databases over the internet instead of buying and maintaining them yourself. Think of cloud computing like Netflix. Instead of buying and storing movies on DVDs, physical servers, instead of buying physical computers, you stream them on demand from the internet, cloud computing. Example is, excuse me, instead of buying expensive servers, a company uses AWS to rent computing power and storage, only paying for what they use. Literally, if you had an idea back in the day and you wanted to start a business, you had the application, you coded it, and you wanted to create a server, build a server, you're looking at a lot of money, like a lot of it, like buying a server is not cheap. So instead of you paying a lot of money to even test out of this, if this idea of a business will work, you would have to have a lot of upfront cost. Instead of doing that, hey, you can just rent. Like instead of paying five figures, 10,000, 20,000, 50,000, whatever it takes to like build your server, your infrastructure, your physical infrastructure, you can just rent out what you need with AWS, paying pennies on the dollar, micro pennies on the dollar, actually. Instead of paying five figures, you can test it out just building an EC2 and running your application on, running your software on your hardware, running your application on your virtual computer, running your application on your EC2 instance, your EC2 instance. Key cloud components. Servers is number one. They are powerful computers that store and process data. Okay. You can run applications on there too. It's literally like a computer. Like servers is literally a computer. Storage. Okay. Storage is where data is saved, like a hard drive. In AWS, there's something called S3, and you can store folders and files on there. Keep that in mind. So the key cloud components, number one, servers, right? It's pretty much a computer. AWS, literally, they have a bunch of services. AWS stands for Amazon Web Services. AWS has a bunch of services. Okay. Let me go ahead and share my screen. You guys on IG, you guys can see my screen. It won't be perfect, but yeah. Okay, so this is AWS. Okay. Literally says right there. Oh, wait, you guys can see it. My bad. One second. So this is AWS. Okay. This is the dashboard. If I click on the search, or if I click on this little icon, I can see all the different categories: compute, containers, right? All this other stuff. If I go to compute, right, these are all the different services. EC2. Okay. This is a service. Okay. If I go to, I was just talking about S3. So let's go to storage. I'm going to see S3. I just talked about that. That is where you can store your folders and files. Okay. So literally, I'm not going to go in depth with this, but this is a folder, and these are like my files. It's literally like a computer. Just like I have a folder here, and there's files in that folder. This is my folder, and these are my files. You can look at it with the icon, right? It's like a paper. It's like a little folder. Cool. Cool, cool. I see you. I see you, Felipe. Go ahead, do your thing. Okay. Cool. I just want to show you that AWS has a bunch of services. Okay. You do not need to know every single one of them. You don't have to, no, you ain't doing that, especially in this program. Some people try to do that, but no, you just have to know the important ones, which is like five, and then you build on top of that. So, anyways, so let me go back. Cool, cool. Now, key cloud components. One is servers. AWS has EC2s for that. Okay. It's a virtual computer. Just so you guys can visually see it. EC2. Okay. EC2. Cool. The second one is storage. Storage is where data is saved, like S3. It's right here. The third key cloud component is networking. Systems that connect computers together securely. And we use VPC for that. Stands for virtual private cloud. We'll go over that. You don't have to worry too much about that because that's another section. But virtual private cloud, if I go to, I think it's networking, VPC is a part of that category. Isolated cloud resources, but nonetheless, I won't go in depth with that for now. And then So yeah, that's the main three key cloud components: servers, storage, and networking. A business uses AWS EC2 for computing, S3 for storage, and VPC for networking to run their applications in the cloud. Now, there's three major cloud providers. AWS is the biggest cloud provider, and it's known for scalability and a wide range of services. Microsoft Azure is used by businesses that already use Microsoft products. Google Cloud, they call it GCP. So let me keep it simple. There's three main cloud providers. AWS stands for Amazon Web Services. AWS, Azure, and GCP. AWS, Microsoft Azure, that's the full name. People just call it Azure. Yeah, do you have any Azure experience? Yeah, I do have Azure experience. Hey, do you have any AWS experience? Yeah, I do have AWS experience. That's like the link. That's how we talk. Do you have any GCP experience? Yes, I have GCP experience, right? Google Cloud Platform. There's three main cloud providers. Cloud providers, think about it like you have Target, you have Giant, right? You have Walmart, like Walmart and Target. Think about it like those two. Let's compare those two. They sell clothes, they sell like food, right? Like they're like the big dogs. They like in the cloud space, in the cloud market, Amazon, which is the company, they have the most shares in the market when it comes to cloud. That is a direct relation to AWS having more jobs being available, more opportunities because they have the most market shares in the space. That is primarily why I choose AWS. That's why I'm teaching AWS because there's more opportunity. The other company is Microsoft. They have their own cloud thing. Like they have their, like literally, put it like this. A virtual computer, you guys know what that is. It's literally a computer somewhere else that's rented on, that's on a computer. It's a computer within a computer. And AWS, they called their own version of virtual computer EC2 instance. Microsoft Azure, when you go on their platform, when you go and log in, they call their virtual computer virtual machine. GCP, forgot what they call it. But literally, each platform, each company, they literally have the same stuff. They just call it something different. So you don't start and, I want to learn all three. No, just choose one and be really good at that. What's going on, Marcus? Oh my God. It's been a minute. Okay. Anyways, so now that's the main three top dogs, but there's still other providers. There's still other cloud providers. I just told you the main three cloud providers: AWS, Azure, and GCP. No, you don't want to say, "Hey, yeah, I know Amazon Web Services." That's so weird. Someone can tell you you're not like. There's no way you have 5 years of experience saying that. We say AWS, we say Azure, we say GCP. There's other providers like IBM Cloud, Oracle Cloud, Alibaba. Yes, Alibaba has its own cloud provider. Cool. Anyways, now we're going to learn lesson 6, cloud computing models and benefits. So, cloud computing models and benefits. First one, the first model is infrastructure as a service, the building blocks. So, infrastructure as a service, it provides virtual machines, storage, and networking over the internet. Where did I talk about virtual machines, storage, and networking? So I talked about the key cloud components, which was servers, storage, and networking. And then I showed you on the screen EC2, S3, and VPC. right? And so now infrastructure as a service provides virtual machines, storage, and networking over the internet, like renting raw infrastructure. Imagine renting an empty apartment. You bring your own furniture, decorations, and appliances, which is like software configuration. An example, an AWS EC2 virtual machine and S3 storage are infrastructure as a service because they give users full control over how they set up their infrastructure. That is infrastructure as a service. And this is more of a concept, not like an actual, like this is more so of a concept. And I'll explain in a second. Platform as a service is a ready-to-use development environment. Platform as a service provides a platform for developers to build and deploy applications without managing infrastructure. Those who are on projects or tech challenges, ECS, EKS is an example of a platform as a service. You don't have to worry about, sorry, scratch that. Something like Fargate, something like if you do not have to manually install a virtual machine, all you have to do is like, hey, here's my application, here's my containerized application. I'm gonna run it on this thing. One of the things you can run that an application or a software is something called Fargate. But just to make it very simple, the first thing I explained was hardware and software. Typically, you have to buy a computer. Typically, you have to create an EC2 instance and then install WordPress on there. That's project number one. Those who are not on project number one or Tech Challenge, don't worry, it will make sense. But all I'm saying is infrastructure as a service is you going out there and building the EC2, you configuring it. Maybe you literally install the operating system. You choose what operating system you want on your EC2 on your computer. You choose how much storage, how much RAM, right? The instance type. You choose all that. You have control over that. And then you install WordPress. Platform as a service is like you do not control the infrastructure. You do not control the computer. It's already there. All you do is just, hey, what software do you want to run on the hardware? Going back to what I taught, I said hardware and software. Hardware is something physical, software is something that you run on the hardware. Platform as a service is a platform for developers to build and deploy applications without managing infrastructure. Platform is like renting a furnished apartment. You just move in and start using it without setting anything up. There's a service in AWS called Elastic Beanstalk. It automatically handles server setup, networking, and scaling. So developers, people who code, software engineers, they only focus on writing code. They don't have to focus on the infrastructure aspect, like how much RAM, how much storage do I need for my application to work. It handles that all, like it does that for you. You don't worry about that. Software as a service, most people have probably heard this, right? But it's a fully managed software. Software as a service provides fully functional applications over the internet. No need to install or manage anything. Software as a service is like staying in a hotel. You just use the service without worrying about cleaning, electricity, or maintenance. Example, Gmail, Netflix, Zoom, Dropbox, Google Drive, sorry, Google Docs, right? You just log in and you use them without worrying about how they run. That's typically for users. Users is like, when I say users, I mean like people that are using the computer, like a consumer. You guys are not typically users anymore because you're on the back end. You are the administrators. You are focusing more so on platform as a service and infrastructure as a service because you're building the virtual machines, you're like deploying the applications on there, as opposed to using a software as a service, which is more so using the application like Gmail, Netflix, Zoom, Dropbox. Okay, cool. So those on IG, my glasses is about to die. So I'm about to switch. Those who are watching the video, because this is recorded, um, I am just switching from IG from my glasses. So, anyways, let's continue. Now, the benefits of cloud computing. You don't need to buy expensive hardware. I already talked about that. You can easily increase or decrease resources as needed. Um, I'm not going to go super in depth, but hey, you save a lot of money. It's more secure. Like you can scale, you can scale up or down. When I say scale, back in the day, it's just an example. I used to want to buy shoes. A new shoe's coming out, and I go and let's say it comes out on Friday. Friday like 12 o'clock a.m. and then the shoe is released. A bunch of people are trying to reach the website. If there's too many people trying to hit the website and there's like nothing to handle that, like the amount of people reaching it, put it like this. It's like my apartment can only fit 50 people. And if at 12 o'clock, now there's 100 people trying to enter my apartment, it cannot fit and it'll crash. Scaling means like I can go ahead and like create more space in my apartment. So if I have my website and there's 50 people that can only go there and 12 o'clock happens and because people, it's a new shoe. People are trying to get the shoe. And too many people hit the website, it will like AWS, you can automatically scale up to handle the workload. So it won't crash. So that's the benefit. As opposed to you having it is a physical server. And like if you need a scale, you literally need to buy a server, which costs a lot of money. You need to go ahead and wait for it to show up to your place. You need to wait for it to once you have it, you need to configure it, which takes time. And then you need people to manage it. Like that's just so much work as opposed to just clicking a button and you can scale. Or you can set it up in a way where you can scale automatically. It's the benefits of cloud computing. Cool. AWS core services. Okay. AWS core services. So AWS offers a variety of cloud services to help businesses build and manage applications efficiently. This is why they are paying us a lot of money because we know and understand this skill. Businesses need us because they need to be able to switch their IT stuff from the physical to the cloud. And there's still a lot of businesses that has the physical. AWS offers a variety of cloud services. I gave you an example and I showed you it on the screen to help businesses build and manage application efficiently, more cost effective, more scalable. So if the website goes down, like Instagram or Netflix, when Jake Mike Tyson and Jake Paul was fighting, like it was kind of like laggy. Like that's down. Like if Instagram goes down, they lose multi-millions of dollars. Like I'm talking about 2, 3 hours. So anyways, I'm going on a tangent. I just wanted you guys to understand that's why they pay us six figures because we prevent that from happening because we have the skill set to set it up the right way. Anyways, AWS core services. AWS offers a variety of cloud services to help businesses build and manage applications efficiently. Think of AWS as a giant toolbox. Each tool service, okay, helps you build different parts of your project. Okay, cool. Each tool helps you build different parts of your project. Yeah. All right, cool. So, for an example, if you need storage, AWS has S3. If you need a virtual server, AWS has EC2. So the key AWS core services, right? EC2 is a virtual computer, virtual server, virtual computer. Okay. S3, okay, this is for storing data. RDS is for database. Okay. And VPC is like a private cloud network. Okay. Cool. And if, like I said, all the stuff that you're like, yo, what is that? What is RDS? What is VPC? I talk about that. I'm gonna still talk about that because that has its own section. Okay. Cool. People on IG, I'm just adjusting this tripod so it can be a little more big deal for you guys. So, all right, cool. Anyways, it sucks. All right, cool. Got it. Now, moving on. Like for an example, a company hosts its website on an EC2 server, stores user images in S3, and manages customer data using RDS, which is a database. Like we're using different tools to create a solution to help a business run effectively, efficiently. And all you need to do is just learn the tools. It's very basic, very. Once you learn it, once you've actually used it, once you've ever like done it, now you know. Okay, cool. And it is 9:27, and we have gone over everything we need for today. So the goal was some like in the boot camp, this would have actually we're on day two, actually on week one. But nonetheless, something that would take 2 hours, probably doing it in 45 minutes to 1 hour. I'm getting straight to the point, teaching it, and yeah.